interesting than a linear relationship, right? Linear relationships have a common difference. You're adding each time as you're like moving through the sequence. Exponential relationships, you multiply each time as you're going. So they grow. Do you think they grow faster or do they grow slower? That's like this. Which one is going to grow faster? The linear or the exponential? Faster? Yeah, the exponential ends up growing a lot faster. Or you can go back down the other way and it can decrease a lot faster. But the growth rate is always going to be bigger for an exponential relationship. But before we kind of start talking about like exponential relationships, we need to just talk about exponents. So a lot of this stuff you should have learned in middle school, but let's just refresh our memory. So first thing, when I have this right here, 4 to the third power, or 4 cubed, 4 raised to the third, not 4, 3, not 3, 4, not 4 over 3, not 3 over 4, 4 to the third power, right? We need those prepositional phrase in there. What is my base in 4 to the third power? 4. And what does that tell me? What does that mean? What's the significance of the 4?
It's the number that you're multiplying.
Yeah, it's the number that we're multiplying. And what is the exponent in 4 to the third power? Yeah, it's how many times to multiply, but in 4 to the third power, what is the exponent?
3.
Yeah, 3. Good. 2 multiply. Okay, and 3 was the exponent here. And just to be really clear, 2 to the third and 2 times 3, those are not the same. How are they different? How are they different? Yeah, exactly, right? 2 times 2 times 2 is what 2 to the third is. And what does that equal? That equals 8. And what does 2 times 3 equal? 6. Yeah, 2 times 3 is 6. And 2 times 3 is really 2 plus 2 plus 2, right? Exponents are repeated multiplication. Multiplication is repeated addition. Cool. So what we're doing down here is we're looking at different properties of exponents. So when we have the same base, we have a couple of shortcuts we can use. So for number 1, I've got 2. Do you guys need to have a conversation in the hallway or something? Okay, you stop. 2 squared times 2 cubed, right? That's 2 times 2 times 2 times 2 times 2. That's expanded form when we write it all the way out like that. What do you think it's going to be in exponential form? Two to the 5th power. So exponential form means it has an exponent, right? So up here, 2 times 2 times 2, that was my expanded form. 2 cubed is exponential form. So now I've got number 2, I have 3 to the 4th. That means 3 times 3 times 3 times 3 times 3 squared, which is just 3 times 3. What do I write for my exponential form here? 3 to the power of 6. Perfect. 3 to the power of 6. 4 squared times 4 to the 5th. 4 squared is just 4 times 4 times 4 to the 5th. So 4 times 4 times 4 times 4 times 4. What's my exponential form?
4 to the 7th.
Perfect. 4 to the 7th power. Excellent. And I've got 5 squared times 5 to the 4th times 5 cubed. 5 times 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 5. How many 5s do we have? 9 of them, yes. It's a little annoying to write it out in expanded form, isn't it? I don't know, I think it's kind of annoying to write out numbers that many times. Do you guys see a shortcut that I can use? What can we do? Yeah, we just add the exponents together. So when we are multiplying numbers that have integer exponents, so just a number as an exponent, if they have the same base, all I need to do is add the exponents together. So let's look at number 5. We can skip over the expanded form now. And what am I going to write for exponential form? Yeah, so that's expanded form, right? 10 times 10 times 10 times 10, 10 cubed times 10. What is it as exponential form? Yeah, 10 to the power of 4, right? On this 10 here, this lone 10, that has an invisible exponent of just 1, right? So I add 3 plus 1 to get to 4. What's it going to be for number 6? We can skip over expanded form now. Let's just go to exponential. What am I going to put for that one? Yeah, 10 to the 10th power, right? 5 plus 3 plus 2 gives us 10. How about number 7? Mm-hmm. And what about number 8? P to the 10th power. Good job. Yep. Again, I have like an invisible exponent right there on that P. So 1 plus 5 plus 4 gives me 10. Good. So when we're multiplying with exponents, we just add the exponents. And then we'll come over here, and now we have raising a power to a power, so an exponent to an exponent. So for this one, I have 2 cubed squared. So that just means 2 cubed twice. 2 times 2 times 2 times 2 times 2 times 2. So what is this in exponential form? 2 to the 6th power. And then we'll do the same thing for number 2. So 2 squared cubed. So 2 squared 3 times. Still 2 to the 6th. How about number 3? I've got one more set of 2s. So 2 times 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 2. Yeah, 2 to the 8th. And number 4, 2 times 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 2. How many 2's do I have at number 4? 9 of them. Number 5 is a repeat. No, to do number 5. What's my pattern here? You guys, can you stop? Yeah, we multiply the exponents, right? 2 times 3 is 6. 3 times 2 is 6. 4 times 2 is 8. 3 times 3 is 9. So the base stays the same. We multiply the exponents. So that's our rule down here. Multiply the exponents. So now we can skip over expanded form. And what's my exponential form going to be for number 6? Good. A to the 10th power, right? 2 times 5 gives me 10. Number 7, perfect, W to the 15th. And number 8, perfect, G to the 15th. Okay, so we're just multiplying exponents here. Let's flip over to the other side, please. Okay, now we have division. And let me just remind you of a couple things before we get started on this. If I see this 2 over 2, what does that equal? 1. And if I multiply 1 by anything, what does it become? Yeah, itself, right? It doesn't change anything. If I multiply anything by 1, it's not changing anything, right? So in here, I have 2 to the 5th divided by 2 squared. So that's 2 times 2 times 2 times 2 times 2 in the numerator divided by 2 times 2. What I'm doing here is I want to look for like pairs, top and bottom. So I've got a 2 here and a 2 there. Those can cancel out, and that's just 2 over 2, or 1. And then this is just 2 over 2, which is 1. And then all I'm left with is those 3 other 2s, so 2 cubed. Next one, I've got 4 to the 6th divided by 4 squared. So 4 to the 6th over 4 times 4. So I find a pair of 4s, find another pair of 4s, and yes, I have 4 4s left over, so that's 4 to the 4th. Does anyone see the shortcut?
Subtract it.
Yeah, subtract the exponents, numerator minus denominator. So number 3 is going to be what? 5 to the 4th. Yes. 5 to the 4th. Number 4, 3 to the 2nd. Number 5, 10 cubed, 10 to the 3rd. R to the 2nd, or R squared. Good. Number 7, S to the 4th. And number 8, M to the 7th. Good. So again, when we're dividing with exponents, we subtract the exponents. Okay. So this half of the paper over here, the create and evaluate, I want you to rewrite these rules. So like for dividing numbers, you just write subtract the exponents, and then fill in what you do for a power to a power, as well as multiplying, and then find the formula that tells you the rule as well. Okay, so circle A, B, or C for each of those. And then you can turn that in. Turn that in, and then grab the Tuesday paper if you haven't already. And this Tuesday paper is going to be due at the end of the week. Okay? Okay. And in this Tuesday packet, I wouldn't start with the first page. I would start with this second page. It says multiplication and exponents at the top, and then looking back with exponents underneath. Okay? So this second page is what I want you to work on when you're done with this first one. And that first one should get turned in to the inbox.